Good afternoon, ladies and gentlemen, and also good morning for the guests from the Europe. Welcome to the webinar organized by Ringer Trade Media for Husky Technologies. The topic of today's webinar is how demand for recycled PET is growing globally and the right way to integrate it into your packaging. For our agenda today, we will firstly have a presentation by our three expert speakers from Husky Technology. Then following is the Q&A session. Delegates, if you have any questions, please feel free to type in the chat box. Our speakers will answer them in the Q&A session later, right after the presentation. First of all, we'd like to welcome Husky Technologies to come to Ringer's live broadcast room again. Since 1953, Husky Technology has been pioneering technologies that enable to delivery of essential needs to the global community with industry-leading expertise and service. We have three speakers from Husky Technology today. The first speaker is Mr. Philip Parubets, General Manager Business Development, Husky Technologies. He joined Husky in 2006 as part of the engineering team in Canada, and he has since held a number of progressive technical and management roles within the rigid packaging business in Canada, Singapore, China, Thailand, and now in the United Arab Emirates. The second speaker, Mr. Spakti Satriwiban, Product Manager Beverage Packaging, Husky Technologies. Spakti joined Husky in 2005, and since that time he has held a variety of positions throughout the sales and sales support organizations in the area of injection molding equipment for PET preform, beverage closure, and packaging applications. In his current role, he is focused on technical solutions for PET systems and tooling for Japan, Korea, Southeast Asia, Australia, and New Zealand. The last speaker, Mr. Pedro Oliveira, Business Manager PET Systems, Husky Technologies. Pedro joined Husky in 2007, and since that time, he has held a variety of positions throughout the organization in the areas of sales support, factory planning, and business development. So now let's all welcome the speakers. And let's begin our live presentation. Mr. Philip Parabets, you may have the floor now.
Good afternoon, and thank you for everyone for attending this presentation called How Demand for Recycled PET is Growing Globally and the Right Way to Integrate it into Your Packaging. As mentioned by Jack, my name is Philip Rubit, and I'm the General Manager for Business Development. Let us begin. So just to add to Jack's earlier comment about Husky, I'd like to mention that Husky has been in the business for over 70 years. And in fact, we are one of the pioneers of PET packaging since it has begun in the 1970s. And in fact, PET packaging represents over 70% of our business today. And recycled PET technology is becoming an ever-growing part of that business. I believe before we begin, it will be helpful to discuss some definitions and facts and get the big picture of what recycled PET is, a short form for rPET. And we start our story with PET bales or PET bags. And whether it is a formal collection, usually it is organized in PET bales. If it's informal collection, usually it's organized in bags of PET, which comes to the recycler. This feedstock enters the recycler and it goes to the first step, which is what we call the sorting and washing step. Oftentimes, you have one piece of equipment that does both sorting and washing. Sometimes you can have two separate pieces of equipment that you can combine together to do the sorting and washing. The input of this step is going to be, of course, the PET bales or the bags of PET coming into the equipment, and the output is going to be the washed and clear blue flakes of PET. And there are many steps in between, including a lot of mechanical separation, where, for example, at the first step, we have a step to break the barrels, the bales of PET. We have a trommel to separate some of the coarse contaminants like caps, like bottles, etc. We include magnetic eddy currents to remove magnetic contaminants. There are jets of air to remove contaminants like labels and etc. You can also include some type of vision inspection system to remove, for example, colored PET bottles. And then at one point, you're going to grind those PET bottles to make flakes. And then in the flake stage, it is possible to, again, to do some mechanical separation, which is done at the sorting stage, including, for example, a zigzag filtration system that has the PET flakes fall to the bottom and some of the lighter materials fall to the top. The next step is the washing step, where we have a combination of different washing steps to seriously wash the surface of the flake. And also there is a float sink step usually incorporated there, where the lighter materials flow to the top and the PET flow to the bottom. And all in all, when all these steps are conducted, you end up with that washed flake at the end. And this type of setup is very common for many recyclers out there. Their output is going to be that washed flake, and there are many different types of applications which can use this type of washed flake, and they stop there. The question becomes is, what about food grade applications? And here, when we're doing the sorting and when we're doing the washing, there's still volatile contaminants within the middle of the flake, and that needs to be managed before we can consider food grade applications. So in this food grade application, what we need is an additional step, and here we call it the decontamination. And here again, it's usually one separate piece of equipment for the decontamination. Some OEMs provide all these solutions together. Some OEMs offer specializing in either decontamination or some of the other steps. The input for the decontamination is going to be that washed flake, and the output is going to be food grade recycled PET, which can come in the form of pellet shape or can be in the flake shape. There are many different technologies available for decontamination. But one common thread that unites all of them is the fact that we apply a lot of heat and we apply a lot of time in order to remove the volatiles which sit in the middle of the flake. Typically, decontamination technology includes an extruder step, which will melt the flake and pelletize it into PET pellet. And usually there's a filter in between, and of course there's a decontamination. So you have all those four steps within the decontamination, and different technologies will put them in different orders. Sometimes they'll do decontamination first and the pelletizing and extruding later, or it could be vice versa. Result nonetheless is going to be food grade recycled PET. If we're considering the pellet, the food grade rPET in pellet form, there are two shapes that we commonly see. Either we're going to see a cylindrical or cubical recycled PET pellet, or sometimes we see spherical pellets. And by virtue of the fact that a lot of the pelletizing in the decontamination step is done underwater, we often see that the pellet shape comes out spherical, which is fine, whether it's spherical, whether it is cubical or cylindrical. All of it will work in the injection molding process. We just need to keep in mind that a spherical pellet is more difficult to generate shear energy, more difficult to melt. So we need to have some consideration in the scoping of the injection molding screw, the extruder, and the process to make sure we properly melt the material. And finally, this recycled PET is injected in the injection molding machine, which produces the preform, and ultimately it makes the bottle. So recycled PET does support bottle-to-bottle recycling. Here we can have a circular economy. And now let us discuss how recycled PET fits into the broader picture of different types of feedstock available in the market. So of course we have virgin recycled PET, and virgin PET can be combined with recycled PET in different percentages, ranging from, let's say, as low as 25% all the way up to 100%. Typically, we're seeing a lot of bottlers opting for 100% because the market feedback that they get from consumers is that when you have 100% recycled PET bottle, that resonates more regarding sustainability than if you have, for example, a smaller percentage. But there could be challenges that limit you from employing 100% recycled PET, and that could be, for example, the availability of the material, or in some cases, the cost of the material. Sometimes colorant is added to the recycled PET, regardless if it's mixed with virgin or not. We're seeing sometimes a light blue colorant or some other types of colorant added to the mix in order to mask some of the discoloration we see with recycled PET. And the challenge here is that the colorant itself acts like a lubricant. So when you combine the lubricant effect of the colorant together with the fact that you have a spherical pellet, it makes the mixing even more challenging here. So again, we need to be very mindful about the technology we have, the proper sizing in the extruder, and the process that's being deployed to injection mold the preform. When we talk about virgin PET, we need to understand that it is made from two base materials, so MEG and PTA. And those base materials can be either manufactured using a non-renewable resource, or it could be a renewable resource. One or the other option is available. And here, sometimes we would say like a bio-based resource is what I'm talking about here. This could be corn, for example, or other types of organic material. In either case, whatever the source is, we produce virgin PET and 100% recyclable virgin PET. One example of this is the plant bottle that you might have heard in the past. Here, we're seeing some bottles, let's say 30% is bio-based, or today we're seeing 100% bio-based. Here, this bottle, it means that the PET is manufactured using renewable resources, but the output, of course, is 100% recyclable PET. When you go out to source recycled PET, rPET in the market, whether it is pellet or whether it is in flake form, if you go to a good supplier, oftentimes they're going to provide you some type of specification sheet that accompanies the resin. And here it will include things like the IV of the resin, the crystallinity, the size, the color. In some cases, you should include also the AA level, the acetaldehyde level as well. Husky, we too also have a specification for recommended recycled PET that's used in our equipment, whether it is food grade flake or whether it's food grade pellet. And here again, we specify IV, crystallinity, acetaldehyde, and etc. And looking beyond PET, there are other alternative materials that can be used to make preforms. And we have seen this also employed on Husky machines as well. For example, PETG, PLA, polypropylene, and etc. The challenge with these type of materials is that despite whatever benefits it brings to the table, if you mix that type of feedstock together with PET, it will serve as a contaminant in the PET recycling stream. So there needs to be some type of care taken to make sure those type of materials are segregated out of the PET recycling stream. Now that we talked about recycled PET, now let's take a look at how recycled PET fits into the larger story about sustainability. And when we talk about sustainability, we talk about four different categories, four different pillars of sustainability. First one is recycled PET and the circular economy, which we just discussed about right now, and which we'll talk about further. But there are other aspects as well, including reducing greenhouse gases, reducing the carbon footprint of your packaging. We're also talking about reducing the raw material consumption. We're also talking about minimizing waste or zero waste, whether it's on land or whether it is in the oceans. And arguably, it could be said that recycled PET forms the pillar, forms the foundation of all of these other sustainability goals. It enables the reduction of greenhouse gases, enables the reduction of raw material consumption, and also it reduces waste. Here, let me call out one example. Often we're seeing a lot of interest from bottlers and the industry at large to combine recycled PET and lightweighting. And here we have the effect of reducing raw material consumption, we're reducing our carbon footprint, and also we're using the opportunity to reduce the cost of the package to help sponsor the higher cost of recycled PET material. And even beyond that, Husky is working on, for example, tethered closures, labelless bottles, and also we're developing PET closures. So we're seeing a lot of bottlers out there deploying recycled PET packaging and using the opportunity to combine many of the other sustainability initiatives that are available in the market offered by Husky. Now let us talk about some of the trends we're seeing in recycled PET. And probably the biggest trend that we're seeing is the enormous increase in the demand of recycled PET. And this is caused by the increasing interest and from the consumers themselves. They want to see more recycled PET packaging in the stores, and they want to consume more of this type of packaging. We're also seeing brands are also very interested and very committed to recycle more and to include more recycled PET into their packaging. And finally, we're seeing a lot of legislation from the institutional level to enforce more recycled PET, to enforce the circular economy. So let us explore some of these further. So here we have a map showing how recycled PET is being deployed around the world in terms of how much recycled PET is being consumed in terms of kilotons, and what percentage of all the PET packaging is using recycled PET. And what we're seeing that there are some variants from region to region in terms of how much recycled PET is used, but for the most part, we're seeing that that number is quite low. The maximum here in Western Europe, we're talking about around 17% of all packaging is using recycled PET. So, given these low numbers, we're seeing governments around the world, they're enacting legislation to force the increase of using recycled PET. And they're using two main vehicles to drive this. The first one is increasing the recycling rate. They want to see a larger percentage of bottles go back to the recyclers. So they're putting legislation, minimum requirements about what percentage of the bottles that are released to the market come back to the recycler. So perhaps 20%, 30%, up to 50% by some certain year. And the second way that this legislation is manifesting is in terms of the percentage of recycled PET material that goes into your packaging. So, in addition to the recycling rate, what percentage of bottles have to be recycled, what percentage of each new bottle needs to incorporate recycled content as well. So, both of these, we're seeing both type of legislation being enacted around the world. Where those legislations are being enacted, we're seeing a pretty steady increase in the use of recycled PET. So it's definitely having a positive effect. And here I'm talking about a legislation we're seeing in the European Union that has already been introduced in Australia. We're seeing it in Japan. We're seeing it in North America as well. And because of this success, we expect that more of this type of legislation will be deployed in other parts of the world. So, in addition to this legislation, and in addition to this kind of the government push to support the circular economy, the brand owners and other stakeholders in our industry are not waiting. They are proactively moving ahead to set their own goals with regard to how many of their packaging are being recycled and what percentage of their packaging includes recycled content. They're setting ambitious targets ranging from 25%, 50%, up to 100% in the years to come. All of this is great news. The combination of the commitments being made by the industries, all the different stakeholders of the industry, combined with the legislative push, it's significantly increasing the demand of recycled PET, which is a great thing. The challenge that we face today is that the supply side needs to ramp up, and we're seeing a lot of activity in increasing the rate of supply of recycled PET. So recyclers coming on board, brand owners doing joint ventures with recyclers, us working together with municipalities to make sure those bottles are being recycled. But at this point right now, the demand severely outstrips supply, and as a result, we're seeing prices tend to be quite high, and the availability of recycled PET to be quite difficult to source. So we're seeing sometimes some challenges with regard to the quality of recycled PET available in the market. So now let's talk about some of the examples of recycled PET bottles which are being deployed around the world. And while they're deploying the recycled PET, they're often integrating those other aspects of sustainability we talked about earlier. We're talking about labelless bottles, we're talking about tethered closures, we're talking about lightweighting, and so on and so forth. So we're seeing that bottlers are taking the opportunity to take sustainability to not just one step, but multiple steps at the same time. Let us explore some of these examples. So let us begin with bottled water. And I start here because this is where, in the soft drink category, that recycled PET has really started. Here, let's take a look at the example of Evian in Europe, one of the early adopters of recycled PET. And here they're deploying a recycled PET in a labelless bottle. And here the logo, the graphic, they're all produced by the embossing in the blow mold. So this is a 100% recyclable package here. Danone as well, they have deployed a number of 100% recycled PET bottles around the world in Mexico, Argentina, Spain, and Indonesia. Here too, labelless bottle, and they're using the embossing here to create the logo and also the information required in the bottle. Suntory in Japan, they have also adopted 100% recycled PET. Here again, labelless bottles, but here's an interesting innovation here. They've introduced a carbon clip where they add some information onto the clip itself that they don't need to produce on the embossing itself. For example, some information about the company, some information about the bottled water, etc. They have done that by adding a carbon clip, which is very easy to remove in the recycling step and a very sustainable solution. Another example here is in Europe, we have Nestle for a family of bottles have introduced 100% recycled PET. Interestingly here that they've also reduced the amount of ink that's used because they have a transparent wraparound closure, but they only isolate the ink to that middle segment where you see the Vittel logo mentioned. They're also using less glue as a result of their package development. And finally, the example here is Ice Rivers in Canada. Very interesting solution that they have in Canada. This is a fully integrated recycling and bottled water bottling operation they have. They are working very closely with the municipalities in Canada to collect the PET bottles, and they have set up their own recycling operations where they do the sorting, washing, and decontamination all in-house, making the recycled PET resin, the rPET resin, and feeding that into the in-house injection molding machines, blowing it and filling the bottles all within in-house. And we're seeing some interest with other bottlers around the world who want to adopt a similar type of strategy. Next, we have carbonated soft drinks. So after bottled water in the soft drink category, we've seen the deployment of rPET in the CSD. So perhaps around 10 years ago, there was some concern about whether it would be possible to have recycled PET within CSD applications, but today we see proliferation of CSD bottles all around the world by many different brand owners, all leading brand owners and local brand owners alike who are deploying CSD in recycled PET. Here's an example of Coca-Cola in Australia. They made very significant commitments to incorporating recycled PET across their entire portfolio of products. This includes bottled water, this includes CSD, this even includes aseptically filled products, and even the nitro hot filled products. So across their entire product portfolio, across all categories, they're incorporating recycled PET. In fact, them, as well as other key bottlers, Pepsi, and others, other stakeholders in the industries are working together, in fact, to support the recycling PET industry in Australia. And we're also seeing examples of recycled PET being used in sensitive products. Here I'm talking about juices, nectars, still drinks, sports drinks, and ready-to-drink teas. We start with Innocent, which is a European brand. They are filling juices and they're using 100% of recycled PET. In this case here, they're using 50% recycled PET and 15% of the bottle is sourced from biosourced PET. Second example here is Naked Juice. This is a brand of Pepsi in the past, and here too they're using recycled PET. So whether it is fresh filled juice or whether it is aseptically filled juice, we're seeing recycled PET being used to make the bottles. And last, we have an example in Australia, brand owner Bega. They have formally launched their juice brands in recycled PET, and this year they're launching their liquid dairy products also in 100% recycled PET bottles. So on the topic of liquid dairy, we're seeing a lot of innovation in the liquid dairy category, and it's not just talking about the incorporation of recycled PET, we're seeing a whole shift in terms of other types of packaging materials being converted to PET, which is a far more recyclable material, far more easier to make back to food grade compared to what you can do with the other type of plastic materials. So here for this example, we have Friesland Campina. They've converted from a formula and HDPE bottle across their entire portfolio of products towards PET, and that is 100% PET. They've also deployed a 100 full sleeve that covers the entire bottle, and this sleeve is serrated, so it's easy to remove. It's easy to remove during the recycling step, so it won't be contaminated, making it easier for the recyclers. And the fact it's a full sleeve bottle avoids having to use the glue. Some other types of innovation they've applied here, they converted from a 38 millimeter neck to a 32 millimeter neck. So we have some light weighting as well. And we're also seeing them in the future going to be deploying a tethered closure here. So here we're seeing the full transformation from an HDPE bottle, which was difficult to recycle before, not as sustainable as it could have been, to this much more sustainable solution, incorporating 100% recycled PET and many of the other sustainability features. And even beyond the soft drinks, we're seeing innovation with regard to recycled PET, even in the alcoholic category. Here is brand Diego, which has formally moved from glass to PET to enable distribution via e-commerce. And then after they convert to PET, they have converted to afterwards to 100% recycled PET. So even in alcoholic categories, we're seeing the deployment of 100% recycled PET. And even beyond the beverage sector, when we're talking about foods and sauces, we're seeing 100% recycled PET being deployed here as well. Here, for example, I'll point out Hellmann's and Heinz, two major global brand owners, which have adopted 100% recycled PET across many different jurisdictions and countries around the world. And them, as well as many other type of companies, they're leading the way for the rest of the industry to adopt recycled PET into their packaging. And going beyond even food and beverages, we're seeing a lot of adoption of recycled PET and conversions towards PET in the personal care category. So we're seeing a lot of interest from the major international brands to convert from whatever other types of plastic towards PET, because they recognize that PET is, in their words, the better plastic. And upon the conversion to PET, they're also deploying 100% recycled PET. So we're seeing a lot of interest to convert from other plastic towards PET, but then even in the PET category, transforming from an opaque bottle to a, say, translucent colored bottle. But even beyond that, sometimes even to a clear, transparent bottle, and they're using the product inside to provide the color. So we're seeing that type of innovation being produced as well. Here, I'd like to call out one, this particular brand here on the left, Ecover. This is a European-based brand. They have adopted, or they converted from HDPE towards PET, and today they're launching in 100% recycled PET. They have the carton clip where the additional information for the brand is included there. What's interesting to note here, they've added ridges to the shoulder of the bottle because they recognize the recycled PET might have some discoloration. So they use that opportunity, they use the discoloration as an advantage here. By adding the ridges here, you're able to see the ridges more clearly, and it makes for a good effect for the bottle. So they're taking advantage of some of the challenges of rPET to make into an opportunity. So now I've completed talking about some of the trends we're seeing for recycled PET around the world in terms of its deployment, in terms of brand owners and legislation push to increase the recycling of rPET, and also to increase the percentage of rPET used in your packaging. And I talked about a number of examples in all different types of categories of PET bottles, which are deploying recycled PET, soft drinks, beyond soft drinks, foods, and also in beyond foods in home and personal care. Now I'd like to turn your attention to my colleague Supakti, who he will be talking about the trends that we're seeing in terms of rPET and the different launches there in Southeast Asia. So thank you very much for your time, Supakti.
Hi, Supakdi here from Thailand. Good afternoon. Now let's take a look on what's going on in Southeast Asia. It is an exciting time to be here in Southeast Asia because there are a lot of things happening here. It all started with some regulation change in the last year or so. Here, I want to share with you two example for Thailand and Philippines. Let me start with the Thailand one, the one at the bottom here. Um, Thailand didn't allow to use the recycled material in the food packaging in the past, but all that changed last year. Now it is possible, still subject into some approval, but now we are good to go. Above is for Philippines. Philippines launched the new regulation called EPR, Extended Producer Responsibility. Here I will cover more in detail on the subsequent slide. But basically, what it encourages is that it encourages more more recyclability of the whole supply chain. So with those change in place, now we see different new product made with the recycled PET coming out everywhere: Thailand, Vietnam, Philippines, Indonesia, Malaysia, even Myanmar. Same for the investment. We also see a lot of investment to support those demand. We see a lot of investment in all those countries, especially on the resin supply side. And now, if you see, like we have consumer, producer, and also supplier, where could it still be the challenge to incorporate more recycle into the PET packaging product? Here could be one, okay? The graph on the left show you the collection rate of the PET bottle, okay? All in all, I would say it's still quite low. In the most country, it is still below like 50%, okay? It is quite low. And then when you couple with the higher demand that each of the brand commit to use the recycled material in their packaging, which show on the graph on the right here, today is still quite small. In the next 10 years, it will increase significantly, okay? So low correction rate coupled with the high demand, it would drive the price of the rPET material much higher, and then this could be the problem. But we still see some solution to this, the challenge, okay? One is related to the graph on the left. Basically, behind this graph, there is also another statistic that collect in the major country in each of the country. And in the major city, we see that the collection rate is much higher than the country average. What it means is that there is the way to increase the country collection rate into the higher rate, okay, via more education, better infrastructure, and so on. That's one way. The other way is here. It's called, is from the regulation side. Here is one of the example of the toolbox that the government could use. It's already in place in some of the country like Vietnam or Philippines. It's called EPR, or Extended Producer Responsibility. What it means is that it extends the responsibility of the producer beyond just make the product and sell the product. Now, the government can enforce the producer to be responsible to get that product back through the recycle. This, the EPR, could impose in the different way. One of the way is to set up the recycling rate of the product. Okay. Then once this is in place, the producer can influence it in a few different ways. They could give some incentive, for example, like if the people return their bottle, then there is some money pay back to the people who return the bottle, or they can do more marketing, more advertisement to give more education for the people, so that like they recycle more of the each of the producer, or they can also sponsor like the recycler, so that like the recycler can come up with a different method to try to get the product more back for recycling. Okay, so here with that we believe that the challenge can be overcome. Okay, and the rPET have the bright future. And with that, let me pass on to Predo so that like he can share with you more detail about the technical solution of the how to produce the PET preform using the rPET material.
Thank you very much, Supakdi. Thank you everybody for your time. Very interesting update, Supakdi, on the situation in Southeast Asia. It's really impressive to see how fast things are changing in the region. So from the introduction from Phil, and also from what Supakdi just said, it becomes pretty clear that the challenge is very much linked to how to ensure the circularity of rPET. Supakdi just pointed out about the collection being one of the biggest constraints. What I will go through now is on what are the implications of this circularity of rPET. And the first one that I would like to be very important at this point is to understand that using more rPET means that we add an additional variable to the equation of injection molding. So until now, we were always talking about the conversion technology, the machine, the mold, the application, the process, and now we need to consider the material as an additional variable. So what does this mean? Means that we need to understand, as an industry, we need to understand how does the variability of rPET that is expected due to the fact that we have different bale quality, different sorting technology, different collection, different seasons. The materials are different from different countries. So we will have inherently variability on the source, on the stream of rPET, how this can affect the injection molding process. So Husky is having a systematic approach to understand that variability by testing, by analyzing different rPETs and how does that impact the injection molding technology. One of the things we are doing is resin and preform grading. So collecting different rPETs and understanding how the different variables for the different products, and also matching, for example, as you see in this slide, what is the relationship between solid contaminants on the rPET and preform A's. For example, we see a correlation between those two. There's also other type of approaches concerning crystallinity, concerning IV. So all these are services that Husky can provide. And as I said, so being the material another variable into the equation, we need to understand that there are some risks by running rPET. It's important to talk about those risks and also to see what are the technologies that we put forward to deal with those risks. So rPET is a more sensitive material because it's a material that is already on its second life. So it's necessarily a bit more sensitive. So we need to make sure that we have the right drying conditions. Most of the rPET providers recommend a lower drying temperature. So to ensure that we still have the material properly dried, we need to dry it for a longer time. In most of the cases, we are not producing with 100% rPET, or in some of those cases. So we always need to mix two different materials and to make sure that these two different materials are properly mixed, and we have at the end cavity to cavity reduced variability. So we have the same melt arriving to each cavity. And then, of course, we need to make sure that we have the best possible melt distribution, and we reduce as much as possible any defects due to higher dust creation in the vents, for example. And then we have to whatever we do, if the quality of the material is not the best, we can always have prevailing defects, and this is something that we can also address with our technologies. So here is a bit of a summary of the technologies that are or the solutions to running higher levels of rPET. We start with the dryer, fully integrated dryer, metal separated blender, controls, the upper dimension optimization being something extremely important to assure that we have a proper drying with at the required temperature for a potentially longer time. The melt management and the mixing of the different materials into the dryer and then into the injection screw, extremely important. And I will have a slide later about that, about the importance of our hot runners and the melt management. Then we can see also the system level recipe traceability and specific rPET HMI screens. This is something that we are launching with our new platform, the self-cleaning mold, and then of course, as I said, the post-mold cooling, and also the possibility to integrating downstream monitoring equipment. So these are the technologies that we put forward as a risk mitigation package when you're running rPET. Of course, all this in an rPET proven platform that is the Husky injection molding machine. We've been running systems with rPET since over 20 years. And also the factor of experience is very important here. Therefore, we have our Husky Academy, our training services, process training services, and also our factory planning and optimization services that we can bring forward when your challenge is to integrate more rPET into your packages, and the modifications required in the plant to do so. So here, a little bit more detail on our outrunners. It's a key element when we're talking about rPET. We're talking about variability, and we're talking about variability. We need to make sure that we have the right technologies to reduce or to do not amplify that variability. So that is, of course, done with optimized outrunner balance, but also making sure that the right technology to address or to proactively reduce dust creation by addressing dust root causes, and this is done by our design for outrunners. Here, again, it's about when we talk about virgin, the importance of outrunner balance is clear. It allows us to get tighter tolerances into the finished good. If you imagine that with rPET and with a variation that could even be a batch-to-batch variation, we need to make sure that an IV variation, for example, will not have an effect on your product quality. And this is basically what we can achieve with our optimized outrunner balance, and basically how we deal with variability input, and how our system is the best foot forward to do not amplify that variability. Another very important point is the self-cleaning mold. We know that some rPETs, not all of the rPETs, produce more dust in the vents. So we will need to be cleaning the vents more frequently. What happens is that we will not know, because some rPETs do create more dust, some rPETs don't. So what is important is to have an operator-free and a consistent way to clean the vents automatically, and also ensuring that it is done independently of the material that we are running. And this is something that will contribute for ensure the quality of your finished goods. I'll share here to those of you that are probably. So this is part of our, what I've been talking about is part of our technology, hardware technology, and but all this is part of the Husky Complete, which is the industry-only complete connected end-to-end production solution. So we put together the hardware together with our knowledge, and also with our fully digitalized delivery model, tooling lifecycle optimization. And I will talk about also our Advantage Plus Elite, we call you, together with a digitized OEM part solution, and the Husky Academy that I mentioned before, with the capabilities to provide extensive process training. Here is an example of our factory planning services. A customer in Europe where we were the partner of choice once we provided the knowledge solutioning for the requirements that the customer had to produce with the preforms with 100% rPET. We were able to design, transform an existing facility to the production of rPET and preform production, and we were capable of providing end-to-end single contact project management that was engineered for full traceability monitoring. And then we were able to walk hand in hand for over a year, ensuring that the customer would be in stable production. Our Advantage Plus Elite solution that is the industry most responsive service support. We call you, so we keep monitoring your systems, and we get in touch every time there is a process deviation to ensure that you keep your assets producing at the maximized level. So I'll take also some time to introduce our recycled melt to preform system, which is the world's most sustainable system. It's a system that is designed to be connected directly with a melt decontamination unit, a Canerema or an NGR or the Stalinger line. And this system is basically bridging the pelletizing, all the handling of the pellet, and then redrying and re-extruding. So we have a direct connection from the melt to the injection molding machine. So this, of course, has over 30% energy savings, and also a huge impact on your carbon footprint emissions. So the system is based on our proven HPP5E platform. You see that the machine is, we sold over 600 of those systems. It has exactly the same options, the same mold interchangeability, the same performance. Is an HPP5E system with a modification. We do not have an extruder. We have a melt transfer pipe and a universal connection that is done by also a proven technology of our dual shooting pot. We have already installed one system in 2021. We've sold additional 2 systems. So the first system was installed with EREMA. The second system was sold with an NGR line, and the third system has been sold also with EREMA. And we have other opportunities that are close to be finalized for additional systems in the field. And this concludes my presentation. It was a pleasure. Thank you very much, and feel free to get in touch if you have any additional questions. Thank you.
Let's thank all our speakers' presentation first in the chat box. Let's say thank you. And I'd like to invite the speakers one by one back to the stage for the live Q&A later. Let's thank Philip Harubet and Spakti Sorigwiban and Pedro Oliveira. Audience, we hope very much you can leave your valuable feedback now before we move into our live Q&A so that Ringer and Husky Technologies can always provide you with better service. You can scan the QR code on the screen now to tell us what you think about this webinar. I will also post the feedback form link in the chat box as well. So I'll thank you very much in advance. In the meantime, I would like to welcome all the speakers come back to the stage all together. But the speakers, I have to make it one by one, so please wait for me. In the meantime, delegates, I would like to, have your feedback first. Hi, Philip.
Hi, Jack.
Let's see if we can invite Subti back and also Pedro. Subti, now you are open to the welcome back to the stage. And
Hi, Jack.
then here
I'm back.
is Pedro. All right. So once again, delegates, are you ready? We will go to our live Q&A session now. All right, I guess we can start with some of the question first. Let's see. We will have this. We will have this one first. Let's see. I'd like Philip to answer this question first. Is that all right?
Sure. Let me just reread the question here. So do you anticipate the trend towards minimizing CO2 footprint in packaging in light of the probable future reporting requirements on brand owners around the world? So I do see in many brand owners and even beyond brand owners, I'm talking about all levels of the industry, all stakeholders in the industry, whether they're converters or even material producers, they are including CO2 footprint as part of their sustainability objectives. They are looking to reduce their carbon footprint, looking to reduce their greenhouse gases. And in fact, a lot of brand owners are also including that specifically, that they do want to reduce the CO2 footprint. And this can be manifested in many different ways you can actually reduce your carbon footprint. And packaging is one of those ways. And recycled PET packaging is a really good way of doing it. So we can see that from virgin PET down to recycled PET, some studies have shown that you can reduce your carbon footprint for the package up to 2/3. And so they're combining the fact that first you lightweight the package itself, which also reduces the carbon footprint by itself. And then on top of that, you convert from virgin to PET, which adds an additional carbon footprint reduction. So for the brand owner, this is very interesting for them because they're able to lightweight, reduce the cost of packaging. They're able to do the rPET, which fulfills many other sustainability goals, and they're able to tackle the carbon footprint. So this is to the point I mentioned before, that there's a lot of synergies between the different sustainability goals, and rPET working together with lightweighting and working together with reducing carbon footprint is one of them.
That's right. Do other speakers have anything to add, or let's move on to the next question?
Yeah, I think we can move on to the next question. I just have a question. Can we see, because I cannot see Phil? Maybe it's
yes, we can see each other actually, right, Spakti?
Do you see?
Yeah,
Can see each
I
other?
can see all of us.
Yeah, we can see each other now. Actually,
Great.
we can all see your big face.
It's only me. It's only me then.
Talking about that, yes, I would like to invite Pedro to answer this question. Pedro, can you see the question in the center stage?
Yeah, so I will just repeat also, can existing iPad preform injection systems run rPET material? Yes, the answer is yes. So we've been having, I think I mentioned that during my presentation, we have been having systems running rPET, different forms of rPET since many years. I joined Husky 17 years ago when we had already our customer here close by, LuxPET, which was producing preforms with 20, 30, 40% rPET at that time using completely standard machines. And today we have customers using rPET up to 100% for all types of applications, and doing it in standard iPad machines. So as I mentioned during my presentation, our system is rPET proven, is the most capable system to run rPET. But I'm just saying something wrong, because I'm calling rPET, and there's no such thing as rPET. There's rPETs, and I think this is what I wanted to be pretty clear in during my presentation, is that there is very good quality rPETs, virgin-like rPETs, and there is very bad quality rPETs, and there is all a world in the middle. And to make it even more complicated, there can be the same rPET having a batch-to-batch variation. So we need to think about this problem, taking on that slide I started my presentation with the four variables of the injection molding, and the material is one of them. And yes, you have the best foot forward with an iPad machine, but you might need to have some additional risk mitigation options to make your system more capable and to reduce the risk of running with rPET.
All right, thank you. Let me publish the next question. I think there are several. Yeah, actually, there are more questions coming up. But I will choose the question I think interested for everyone. Oh, this one is short. I'd like to invite Pedro again to answer this question. Pedro, is that right?
I think I answered it in the text box during the Phil's presentation.
Yes.
But I will repeat it. So color variation is just one, following what I just said about the variation on batch to batch or supplier to supplier, season to season on rPET. And one of the biggest challenges that the industry faces, and when we talk with major brands, is about color variation. So there is there was in some cases very stringent color requirements. There is a way to what we've seen, the tendency in the industry is to accept a little bit more variation first, because also the consumer accepts a little bit more variation. Here in Europe, when you go and buy a bottle of Coke, for example, depending on where you go, you might find different levels of color, different color in the bottle. So there is some degree of exception, and there's also the capability of controlling or going, how should I say, to correct those deviations by adding some toner or some color. We are working now on developing a system that does that in an automatic way. So monitoring the color of the preforms and auto-correcting by the means of an additive in order to have a constant color.
Right. Now the next question, I would like to invite Philip. I will invite to Spakti to answer that question. Okay, Spakti, let me find a question for you.
Oh, okay. Let me repeat this
Can
question.
you answer this question?
Yeah, sure. Yeah. What is the premium price for rPET, the raw material, over virgin PET? Actually, like this, the information could be vary over the year. Okay, but we see in general, rPET is more expensive than PET by 20 to 30% by average.
All right.
Okay. Yeah. Okay. Sorry. Just let me add just one thing. As I said, the situation today, the problem is on the feedstock. It's not enough feedstock to make the recycled PET. Okay, therefore you see that the price is higher than the virgin. Okay, but I would say like with the regulation, with the better education and so on, I think like in the future, once we have better circular the economy, okay, around rPET, the situation would be much better.
All right,
And maybe I can just add here that we're
please.
seeing a lot of variability globally with regard to the differential between virgin and rPET. It's very much depending on local supply and demand conditions. It can be quite varied. Maybe in Southeast Asia, it's 20, 30%, but even between different countries, you can have different rates. And in Europe, for example, it can be much higher. So I'm seeing a range between, like, say, 25% up to 50%, even higher in some situations. So over time, it changes a lot, and also between geography to geography. And we're seeing a lot of variability, especially for the rPET pricing, depending on the demand coming, the supply
Correct.
available in the market.
In Europe, now it's at 50%, but it went up to 70% at a certain point last year. So to add to the point of supply and demand is also areas where there is no real option. Right? So due to the legislation and to the need to incorporate a certain amount of rPET, there is less flexibility on the demand side, so which pushed the prices even higher, which was the case in Europe. We saw that the behavior, for example, in the US was significantly different there. So when the demand when the prices went too high, there was a shoot in demand.
All right. I have to remind all the speakers that we are actually running out of time, but I think we still can answer one or two questions. Okay. So the
Thank
next
you.
question, I'll choose a rather short one. Okay. Is it possible to have the rPET specification? So this
Yes.
one, I guess we can invite Pedro again to answer this question.
Thank you. I also answered that in the chat box. Yes, please reach out and come back, and we will provide you with the rPET standard specification. Reach out to me.
All right. So let's have our final question, I guess, if we still have time. Let's see this one. Is anyone else can answer this question? Or we can go to this one. Let's choose one of them. Let's choose between one of them.
For the last question, if you want to get a copy of this presentation, I think we can share part of it. Please, again, reach out to us and just introduce yourself, and we'll be happy to share the parts of the material that is interesting for you, and we'll be happy to answer any other questions you have.
Yeah, that one is rather short, so I guess we can go to another one. So let's see this one. It's good for Pedro or Philip to answer this one.
I think Pedro is the best
Yeah.
person.
Yeah, I think this is the question on the top of mind of everybody. I think there was also another question about haze and on the preforms, and it's basically the same root cause. There's a high connection of this with how the rPET is collected. We realize that. So let me go back a little bit back. So haze on the preforms of black specks, which is the main, probably is the problem number one on the rPET producing right now, is very much linked to solid contaminants. And solid contaminants are linked to how, or strongly linked to how the material is collected. So we realize that everywhere that we have deposit return systems, so the people bring their bottles to a machine or back to the shop, and this is collect. So there is a deposit on the bottle and come back. So it's a very clean collection. The solid contaminants in the recycled PET is lower when compared to the countries where you have what we call normally the blue bag, is where everybody puts all the plastics in the same bag, and then this goes into a sorting line. So the root cause is going all the way back to that, and is mainly linked to solid contaminants. So if you ask me, can we eliminate completely black specks? No. Probably you cannot eliminate completely what is linked to what I just mentioned, to the solid contaminants. What you can eliminate is by having the right processing and the right processing equipment. So you need to make sure that everything else that also creates black specks, which, for example, one may create is dust, you make sure that you eliminate dust and fines from your drying equipment, which for me would be probably the first place you should look at first, and maybe that will eliminate most of the black specks problems you have.
Thank you for answering that. And also thanks to the guest speakers, Philip, Pedro, and Svakti. And thanks all participants for all your questions. Now, yes, let's say goodbye to the speakers. Yeah, on the screen. And thank you all for the very meaningful presentation today. For more questions due to the time reason, our speakers or other professionals from Husky will contact you to answer our questions after the webinar. Okay, so speakers, see you. Bye-bye.
Thank you. Bye-bye.
Thank you. Bye-bye. Bye.
So as I mentioned, I will leave the contact information with all of you. So finally, thanks again to Husky Technologies and our guest speakers, Philip, Pedro, and Spakti, for the very meaningful presentation, very insightful. Knowledge and insights sharing today also. On the screen is our contact information. Welcome to contact us at any time. Now, thank you all for attending today's webinar. Look forward to seeing you again in our next webinar soon. Take care, everyone. Goodbye.